Hi everyone, I'm Arosio Priscilla by name, and I'll be taking you on an introduction class to Python and data science. So this is an overview of everything that we'll be taking within the course. Firstly, we'll be looking at what Python is. Then we'll also be finding out what data science is. And by the end of this course, you should also be able to tell um, how to go about the data collection and preprocessing stage, which has a lot to do with data analysis and data visualization. Because data science typically consists of data analysis and visualization. But without further ado, let's find out what Python is. So, firstly, the first thing you need to know is Python is one of the most commonly used languages in the world. Now, up until the early 2000s, people were making use of programming languages like C Sharp, C++, Java, JavaScript, and the likes. But they found out that a lot of people were shying away from these jobs in tech because, like they were getting scared of the codes. And then all of a sudden, this genius just came, invented Python, a programming language that is so easy to use that it's almost like English language, like basically so easy to use that you could not get tired of it. And to make things even better, it's now like much more advanced compared to other programming languages, and it can be used in various phases from web development to data analysis. You have automation, you have software development. Think of anything. There's almost nothing you can't make use of Python for. In fact, what you can do with Python is limited to your imagination. um, Python is so easy to use that literally anyone that has no experience with codes would like have like absolutely no problem like using it. Then one thing you should understand is another thing you should know about Python is like it has so many libraries, from like numerical libraries like NumPy, where you perform different calculations like mathematical problems and the likes. So on a normal note, like probably you have like this equation to solve or this mathematical problem. Like you can just easily write one or two block of codes, just like import them from different libraries and just get them to do the calculation for you. Like you don't have to do the maths, you can just like build a code to do the maths for you. That's how crazy it is. And another thing again is looking at some of these libraries that would actually be making use of. We have like, for example, I was talking about NumPy earlier. We have scikit as well. Then we would be looking like more in depthly at this like while we're taking the course per se. But you should just know that like a lot of these libraries, like a lot of times, like you don't have to solve like problems yourself. You just need to build the code. I remember this guy Henry Ford used to say like he like people used to say like he didn't like really have the brains, but instead of like having the brains, he hired people to do the calculations, to do the critical thinking for him. So that's just how it's like with Python. Like most times you don't have to stress yourself too much. Just as long as you're able to imagine, then you can build a code to do the rest. And it's actually very simple to do the to build a code. So let's look at some of the key features of Python. The first thing you should know, yeah, we already mentioned that it is suitable for like web development and data analysis. Web development in the sense that anyone who learns Python can make use of it. In fact, like one of the things we'll be teaching you in this course is learning how to create like a login system, especially for people that will be doing like front end or back end web development, and for those who would be going into things like numerical Python, probably like building calculators and all these mathematical systems. We'll actually be teaching you how to create a calculator as well, like import some libraries, get them to do the math for you, stuff like that. Then let's also look at the fact that Python is like one of the most readable programming languages in the world. Like with time, like when you've understood Python to an extent, it doesn't matter like if you see like a code in Java or JavaScript or C or C sharp, you'll be able to easily, like detect like what this code is trying to do, because Python makes it so easy for you to understand like literally other codes once you just see them. Then it is also like free to use, to modify, distribute. Like you don't have to pay a single dime to make use of Python, or worry about like downloading the cracked version of an app or anything like that. Like it's open source code. You can import like your Python codes into like different um folders, applications, and the likes. Then talking about like the applications of Python, like how you can make use of Python. So let's talk about data analysis, which is the major thing that I'll be looking at within like data science. Like for those who are interested in a data science class anyway. So we know that data analysis just has to do with like finding out trends in data and visualizing them. Now, when I'm talking about data, I'm not talking about the usual Glow, MTN, the likes. I'm talking about data from companies, like from businesses of all sizes. In fact, one of the good things about being a data scientist is that there's literally nowhere you can't work in, because all companies need a data scientist. They need to like find out what is going on. Probably like they are selling a particular product. You need to find out like, oh, okay, this customer, or like people who are probably like people who are from Africa are more likely to buy this product, or these are the specific times of the year that people buy these products more, stuffs like that. Like they have to find out like different applications. It's not just limited to that alone. You can also like find out like the demographics, that is the countries where people are like buying a product more, and so many things like that. Like it actually provides insights. Then for people who have dabbled into affiliate marketing for a bit, like you tend to like understand like this marketing campaign ads, like that actually like generates lots of data for you based on the location, like literally like information on the kind of people that you are dealing with. For example, there was this particular survey that went around once, and they did this data analysis of the people who died on the Titanic, and they found out that like the people who were like most likely to die were actually like the lower class, which was obvious because like it was mostly like rich people that were fleeing the ship and all that, followed by the men and some of the children and women, because after like all the rich people had gotten on the the escape boats, most of the next class that followed was like um, the class of women and children. Though not all of them were lucky to escape on the boats. But anyway, let's talk about web development. So web development also makes use of Python in terms of like creating input interface. The input interface is like, for example, you log in on a website now and they ask you to like enter your Gmail and login details. So you need Python to actually do lots of these things. Then talking about like automation, like automation is like the way like Python just helps you to, for example, like if you build a code or if you build a program, you can make use of that same program to do things over and over again. Like you don't have to rewrite that same code all over and over again whenever you want to do that same task. For example, the calculator we're talking about, probably you want to do something on like probably like differential calculus or the like instead of rewriting the code all over again, so you already have like a code that will do that for you. So probably wondering at this moment, like, what exactly is data science? I mean, we've been talking about it, like talking. But what is data science per se? Now, data science is actually built into two phases. Now, I would say three phases, but the third phase is an entirely new field on its own. Like, it's a totally different field. But in this course, we'll be focusing more on data analysis and data visualization, because machine learning is another career path, kind of like software development. So we have the first stage, which is data analysis, which involves collecting data from different sources, probably like it could be income from, like, probably like the income of some workers within a company. Then after you've collected the income of these workers, you'd probably like enter it into a tabular format based on okay, probably like their age, their demography, then also like look at um probably like, let's say we're looking at their happiness levels, for example, so you can also get that as well. So you now interpret this data to uncover insights. So usually what happens is, for example, let's say we are looking at the income versus happiness levels. That is, when people are earning more, are they like much more happier? So when like I actually carried out this analysis at one point in time. Like, I was checking like, okay, people that like earn more, are they likelier to be happier? And I found out like, although money is not the, like, money is not a guarantee that you would be happy. Okay, some people would actually disagree with that. But anyway, we just found out that based on that survey, a lot of people a lot of people who made more were actually like much more happier and showed less signs of depression and anxiety. And yeah, data analysis is not just limited to business, it's limited to, in fact, it is not limited to anything. You can make use of this in medicine, agriculture, think of all sorts of things. Then we have data visualization. So data visualization is like, now you found out that okay, people who have lower income or lesser income are more likely to be depressed, or people who have higher income are more likely to be this and that. You get stuff like that. So what would now happen from here is that you would um, you would share with a lot of people that okay, this is what is going on. Like, for example, you already understand Python. Let's say, assuming you already understand Python, it's not everyone that would understand the programming language. So you need to show them the insights that you've discovered. That is, okay, this person, when they earn so amounts, this is how happy they are projected to be, or this is how less likely to be depressed that they are supposed to be. So you would actually show them like what you understood from that data. You would communicate your findings to um, whatsoever business or whoever you are partnering with. So let's just talk about the data science workflow. Like, what are the phases, what are the steps involved, like when you're trying to carry out the analysis and visualization of a particular project. So the first stage is data collection, where I talk about like gathering relevant data from various sources, such as like, you know, income from a company, or possibly like the number of customers that they are losing per month. You get stuff like that. Or at times this could also be like how likely people are to have a particular disease, or the number of people that might die, like, or basically like you're just looking at different things like in different fields. It's not necessarily like medicine or health or business related or finance related. It could be literally anything you could think of. Then we have data preprocessing. Now, after getting our data, in most cases we have like missing data. So missing data is sometimes referred to as none. or nil. So none or nil is just like a place where you have like no values at all. So you would actually clean out that from your data sets, like, and then you remove outliers. Outliers are like values that are um values that are like not within the range of your usual data, like they are probably like very far. It's like having like 0.05 when the other values are within the range of like 10,000 to 50,000, or probably like age now, like someone specifies 0.05, whereas the usual age should be like 0 to 100 and like that, sure. And then you have the transformation of data. For example, in the case of income versus happiness levels, like most times, like we'll specify like, is this person like depressed? So it will be like a yes or no answer. So those yes or no answers, remember that computer only sees values in digits, which is zeros and ones. So you would actually have to convert that yes and no into like zeros and ones. Probably the zero can now represent like no, and then one would represent yes. So that's what you call transformation of data. Then you have data analysis, which involves like making use of different techniques. You have like plotting bar charts, histograms, and you like stuffs that you basically see in Excel on a normal day, and just like applying them to extract insights from data, like to discover things about whatever data set you have. Then talking about tools and techniques in data science, we have data visualization. So data visualization is basically like, yeah, I was mentioning something about graphs earlier. So the libraries, and then we also said something about Python having lots of libraries. So the libraries you can actually use to visualize your data include tools like Matplotlib, you have Seaborn, you have Tableau, which help you to just like create very beautiful and attractive looking graphs for your data visualization. And from there we have machine learning as well. So machine learning is actually the process whereby after you've discovered these insights, you're now able to predict that okay, this is what will happen. For example, the Titanic data that I was talking about earlier, there was this competition on, yeah, a website called Cargo, where they were like offering people cash prizes of as much as $10,000 because um like they actually do that a lot. They have these data science competitions that you can register in, where you can actually like get cash prizes that would help you out. Or machine learning has to do with like predicting, like making predictions based on what you learn. So for example, we have this Titanic data set. You can predict, okay, the number of people that probably like that would die, like, or like the people that are likely to die or that would not survive that shipwreck. So they found, yeah, so they found out that like most of the men in the lower classes could not survive, and so many other things like that. You can also predict like someone's chances, that is how likely is someone to buy a particular product, or perhaps like if this person is Hispanic or African, for example, like would they continue to use a certain telecommunication service and stuff like that. You also have data wrangling. Data wrangling is just like the process whereby you actually clean up your data. Remember, I was talking something about like removing outliers, removing missing values, and I also mentioned something earlier about how you can just transform your data. That is, data that is in the form of like probably yes and no, true or false, like convert them into like numbers that the computer is able to understand. So like how exactly is Python even like how exactly is it applicable for data science? So the first thing that we should know is Python helps us in like manipulating data. For example, you can make use of Python for cleaning up your data, for visualizing your data, and for understanding like the structure of your data. So usually your data is within like a tabular format that you can just handle. Then we're talking about data visualization with Python. Actually, this is the phase where most data scientists need to work extra hard, take a lot of tutorials online. Like you need to ask a lot of questions online because no one would actually sit down to divulge all their secret tactics to you. So most times you have to like this is the place where you have to like develop yourself because the better your visualizations, the better your chances are of getting a high paying job. So these are like just three major libraries that we make use of for data visualization. Then you can also get like other software or other applications like Microsoft Power BI. Can make use of Tableau, but for like when using Python, you can make use of like internal libraries such as Matplotlib, Seaborn, and Plotly. Seaborn is like Seaborn and Plotly are actually like much more advanced data visualizers because Matplotlib is like it's not like very lively versi. If you want to spice up your data visualization, you can just make use of Seaborn or Plotly. Also use Microsoft Power BI um and Tableau. So talking about machine learning with Python, we have I won't really go deep into this per se because it's not yet a course that we are offering, though we might still offer it later on. But for now, it's not part of the courses that will be provided. But what you should just understand about machine learning, remember earlier we were saying like it helps you like in prediction and in fact like for people who are like diehard football fans, you can actually make use of a machine learning model to predict like okay this particular club would win this upcoming game and stuff like that. So you call that and then we have okay yeah, we have three phases of machine learning with Python. The first one is actually data preprocessing, where we handle the missing values, feature engineering, like changing um characters into like zeros and ones, like, and then we have data normalization. Then supervised learning has to do with things like, for example, these robot dogs that were being developed, they had to like follow this example of like normal dogs, like watch them and practice how they worked. So they were basically like brought up in the same environment as real life dogs to like take on more of their character. And then there's this phase of unsupervised learning where you now leave a lot of this like where these dogs are left on their own to kind of like pick up from their mistakes and improve from there. Machine learning is like you're basically like building a program that has a life of its own, as a program that is able to learn from its mistakes and you know after learning from these mistakes improve on them and get better. So that's why you have like a lot of um applications these days that like probably they will tell you like this system is undergoing maintenance or stuff like that. Like these things are learning on their own, picking up from their past mistakes, and they're becoming better than ever without people even having to rewrite any code. So it's basically the same code that you wrote, but it's coming to life because they are picking up from their past mistakes. So how exactly can you get started with Python? But the first thing you need to do is to like install the library or install the packages that you'll be making use of to run Python. So do not worry, I would provide you with some of these packages when the class resumes. Then afterwards, would run the installer. Our installer actually is Anaconda, but probably like when you guys come for the class, I would share the setup with you. Then after you've installed the um, after you've installed Python, I just talk about like Python syntax and basics. So the first thing you should understand is like how to write like a code, like the block of code, like the do's and don'ts of just like writing code. Then the kind of data, because you can't just put in like any kind of data within your Python code. You have integers. Integers are numbers like ones, twos, threes, 13, 100, 1000, and like the likes. Then you also have strings. So strings are characters like yes, no, true, false. But although like these values would be within they'll be within quotation marks. Strings are actually within quotation marks. So like remember we were saying like computers only understand things in zeros and ones. So it's for that reason that you'd put it in string. Like you'd save characters within string so that the computer can actually take in those values. But we'll dive into more of that like later during the class. So talking about some of the Python libraries and packages we have NumPy, we have pandas, we have matplotlib. We firstly mentioned NumPy earlier when we talked about how it's like a powerful library for like um numerical situations, probably like addition, subtraction, or like building your own calculator system. Pandas usually for data analysis and manipulation. Then you have matplotlib for visualization. So going on to the next, which is data collection and preprocessing. We have different kinds of data. So usually we have structured data. So structured data is data that comes within like an Excel file or like a CSV file. CSV files are actually the files that we're making more use of, but um, we'll see like when the class starts anyway. And then you have unstructured data. So unstructured data has to do with like data on like web pages, social media, where you're just gathering this data based on like okay, I noticed this stuff like on this platform, and then you're imputing the data by yourself. And then we now have this semi-structured data, whereas the data is not even like structured at all. Like you're just gathering them from like um probably like from research that has already been done before, but they are not like in the particular formats that you want them to be. So you have to actually re-engineer the data, like tailor it to your needs. And from there, we move on to data cleaning and transformation. Remember that we said, like when you want to carry out analysis or visualization of the data, the first and most important thing to do is to clean up your data. And data cleaning and transformation involves three important processes. The first one is identifying and handling missing data. Probably this probably like for example like a data set or data um that has been gathered into like rows and columns. Now this data that has been gathered into rows and columns, usually you find out that most of this data like the probably like someone didn't fill in their age or they were not sure about the age or maybe the gender or stuff like that like related to a particular person, so they decide to just leave that column empty. So what you will now do is you just like sometimes you can either choose to delete the data or you can find out the mean of all the data and make use of it. But we'll explain more on that later. I don't want to bombard you with too much information now so that you don't get confused. But I promise that like as the class continues, it gets more interesting and you're able to understand like more on the real life applications of data science. Then we also have feature engineering. Remember that I was mentioning that feature engineering has to do with like changing your data into into like formats where you have like yeah, for example, you have true or false. You change them to like zeros and ones, and you basically like manipulate your data so as to get like the results that you want to have, and you also want to improve like your model performance. For example, let's say you decide to build a machine learning model that can predict things, so you actually need to make your model very accurate. And that's actually one of the crazy things about machine learning. Machine learning has to do with like ensuring that your model is so accurate that it's almost close to perfect. And that is where like that's like the major headache of most machine learning engineers, because they have to find out like, okay, am I actually like, are my models actually this good, or are they actually this bad? All right, so moving on to statistical analysis. So statistical analysis is also like another phase of machine learning. You basically like explore data, like find out trends within data, like find out patterns. Then from there, you can create like tests. That is, you can test probably like, okay, you pick out one of those people, enter their details, and find out that is this person likely to buy this particular product from this store, or just basically like, is this team likely to win this match, and so many other things like that. Like carry out tests, find out like, okay, how right or like how wrong is this. And then talking about like model relationship between variables, for example, you have like income level, you have happiness levels. These are all variables, that is, they are all columns of data that you are trying to find out like, okay, so what's the relationship between them. So obviously like people that earn more, they have like a better relationship with, in terms of like their happiness levels, and lesser stress levels per se. So moving on to the next, let's talk about like how you can create like effective data visualizations. That is, visualizations that actually do the work that they were made for. So the first thing is you have to determine the most important data points to visualize. That is, are you looking at, for example, the case of Titanic, where you have like lots of things that are actually contributing to whether or not people were likely to die. So you actually like show these people that, okay, this probably like gender has an influence on whether or not someone would survive a Titanic of shipwreck, or probably like the income level has like an influence, or even the cabin they stayed in, like how close was it to the place where they were boarding this escape or boat that led them out of out of like their situation anyway. So um without further ado, I'd like to thank you all so much for your time. I hope I've been able to convince and not confuse you to actually give a future within data science and machine learning a try. I'll be looking forward to seeing you all in the class. And feel free to drop your comments in the description below. Like, just let us know like which questions you have regarding data science, and I would do my utmost best to answer every single one of your questions. All right, have a great day.